So good morning to all. We will in this session we will continue to create the rest of the parts of this screw jack assembly. I will quickly go to the part drawing. We have created so far mm, three parts. The fourth one is cup, and it is made up of cast steel, and it is one number is called in the assembly. Uh, three fourth part is this a front view, a sectional front view, and top view of this is given. It is also cylindrical, tapered cylindrical part, and then the maximum size is 65 dia, and the height is 42. So I will quickly go to the solid part section over here, and I will save it. And summary, I will look up, and then this is serial number 4. I will save it as 004, and it is made up of cast steel in material. You apply cast steel and save this. Okay, in top view I will choose XY plane, and then I will draw 65 diameter circle over here, and then you see the 42 is the total height of this cylinder. Take 42 is the cylinder and hide your sketch. Keep it in front view and go to select this again sketch mode. Go to sketcher mode, select XZ plane, which is front view, and see how this taper has been created. Here bottom it is 45 and top it is maintained as 65 only. You have to draw this slope, outer slope, and revolve it. For that I take extract this include command. I will extract the this plane symmetric line, and also I will extract this top edge, and I will just offset it by the bottom is 45, from the center it is 45 by 2. I will just offset this by 45 divided by 2, that is 22.5, and I will extract this. I will just draw a slope. I need two endpoints here. See, I will just draw this slope. Once my slope is created, I will use this slope as a section and this as my revolving axis. Return to the 3D environment and revolve it using revolved cutout. Select this section, enter, select the axis, and it will ask the direction in which the material is removed. You give outside of this material should be removed. Click on it, revolve it, give 360 degree and right click. Now the material has been removed. Immediately hide the sketch, and now look at the drawing. Inside also the same slope is there with 5 mm thickness. You just go and select this XZ plane again, and then extract this outer slope, offset it by 5 mm, and here the depth mentioned is 12 mm from the bottom, and select this, extract this and offset it by 12 mm. Also extract this center line, and now you close this profile. Whenever you are removing the inside material by revolving operation, you should create closed profiles. If you are removing the outside material, then no need, just open profile is required. Just delete this. You need an axis, just draw here or somewhere else an axis for this. I will return to the 3D environment and revolve it. I will select the sketch and select this axis, give 360. The inside material is now removed. Hide this 360. Okay, now hide this sketch. Look for the other operations which are left over here. And there is a hole over here with the diameter 22.5 mentioned here. It is a simple hole. Uh, just you can pick any of these faces. Choose bottom or inside surface. Any one of I will choose bottom surface, and it is a simple hole. Make it simple, and the diameter is you mentioned here 22.5, and through all option you mentioned there is no finite depth over here. So hole is drilled, and look at the drawing again. There are some semicircular slot introduced here with radius 5 mm. So go there and keep it in front view. Take the perpendicular plane which is XZ plane, and then draw here a 10 dia circle and go back to 3D environment. With the cutout option you just remove this. One slot has been created here. You can symmetrically you can remove it, but I will show you one more command over here. There are 4 slots, identical slots over here, and you can, with the pattern command here, you can see this is a circular pattern, rectangular pattern. If there are repetitive slots are there, repetitive holes are there, you can make a single hole and quickly you can make the replica of it. And I will show you just with this how to use this pattern command. Mm. So now select from this specification tree, select this feature. You can see in the screen area it is going to, when it is selected it becomes red. So select this and select this pattern command, and it will ask the planar face. You click on this, select this top uh, plane, and here you will be entering into the again into the sketcher mode. Here this circular pattern, I am doing circular pattern around this periphery, so this should be on. Just draw a circle here to give a radial path for that, and here count radius, everything is there. Count, there are 4 such slots are here around the periphery of this component. So I will keep the 4 count as it is, and I will just draw a circle of any diameter and give a direction here. Either you can go for clockwise or anti-clockwise. You see the arrow here. When I mention it clockwise, it will, the direction will be changed. You can use either clockwise as well as anti-clockwise direction. Just mention it and don't touch anything here. Just click on return command. You can see 4 such replica identical patterns have been created. Okay, only thing using of these various commands, it will save your time. Saving the time is very important here. How fast you, and this specification tree should look very simple. If you go on doing numerous operation, what will happen? The model memory will be saved large. So downloading and uploading from the server from in industries, these are very simple parts. In industry, engineer has to log in the morning, and he has to studies the design modification and all, to study the design activities. He has to load the entire aircraft or entire automotive assembly systems. For that, your model should be very feasible. So in order to maintain, you use specific commands. Don't use numerous, don't make go on making numerous operations in the model in order to increase the model memory. As long as possible, you keep the model memory as minimum. Okay. Once you go into the industry and worked as engineers, you will come to know all these aspects. This is the basic fundamental thing which the way machine parts are being done in industry using any other CAD packages. This is the methodology for machined parts. For composite part, there is some other methodology. For surface based part, there is some other methodology. For machined components, this is the methodology. That is, you have to take the stock size and you have to remove the material. Same thing happens in NC machine. It will, the stock size is kept onto the machine, and all other operations are negative operations. With the cutting tool, it will remove the material. Okay. Now this part is, I think, finished. We will save it and move on to the next part, and we'll change the color here. Okay. So in this session itself, we will see the next part, that is fifth part. It is washer special, made up of ferrous. Here fifth part details have been given. Very simple part. It requires a 35 mm dia, thickness 8 mm, cylindrical plate is required. I will just open it, save it as washer special fifth part, save it. I will save it as 005, and then go to material table, FE-410W, apply it to the model, and then save it, and take any plane here. What is the diameter? 35 he has given. Draw 35 mm circle here. Add material, thickness he has given 8 mm. I will give 8 mm and hide this sketch. Okay. Now look at the drawing. There is a countersunk hole here with countersunk dia 25 mm, and then the shank dia is 14.5, and this countersunk angle is 90 degree. Directly go to the hole option, select the top face and go to hole options. Here's type, change it to countersink, and then give the diameter 14.5 as shank dia, and countersink diameter he has given as 25, and countersunk angle you change it. It is not threaded, so there is no threads here. And just give through all option here. Through all I will give and place it at the exactly at the center. You will see the, you can check the preview of that hole, keeping it in wireframe position. You can see the countersink hole has been drilled over here. Now just there is nothing much in this washer. Just these sharp edges to give some 0.5 mm radius. Hide all reference plane and change the color if possible. I use contrast colors because okay, and that's it. And we will quickly move to the next part, that is go to the part drawing. uh, there is a CSK screw. Sixth one is here itself. You can see this is the countersunk screw, which is made up of Fe410W. And I will go to the solid part quickly, and I will mention that, include the attributes. CSK dash, the CSK stands for countersunk screw, and its serial number is 6, and I will 006. I will save it, and then go to material table. It is also made up of ferrous 410W. Now take any plane over here, and its diameter, it is also cylindrical. 30 is the maximum length, and 24 is the dia. I will draw a 24 dia circle over here, and then I will create this. Use symmetric, your choice. In one direction also you can create the material, and now keep it in front view. Take ZX plane as your sketching plane, and then draw the outer shape here and revolve it. You will get the final result. This is 90, then half of this will be 45. Then depth is 6 mm he has given. Here he has maintained 12 dia. I will just, using these details, I will draw this, extract this, offset it by 6 mm, and take this top edge and constrain it, and draw a line from this edge and maintain this angle as 45, and trim this. You little bit extend this inclined line. Sometimes at the edge it will, your operation will not be performed. Extend this profile. um, this is it, and this is acts as a section, and this is the symmetrical axis. Use revolve cutout operation. Select the sketch, right click, select the axis, change the direction, give the direction here, and give 360-degree angle at the upper side here. Enter, right click. The material has been removed. Quickly hide this sketch. Now I think there is a slot. There is a slot here 2 mm on the head of this CSK screw. 2 mm and 3 mm depth he has mentioned. Go to the again front view. select this ZX plane, quickly zoom it, and quickly you create a rectangle slot here, constrain it. So width is given as 2 mm and depth he has mentioned 3 mm. Go back and using the cutout option, select this profile and then make it symmetry. 24 is the depth, so the cutout has been introduced, and then hide all your reference planes and give this edge a little bit of chamfer over here. 0.5 I will give, and then see the drawing here. This is a threaded shaft. So some 2 mm or 3 mm he has not mentioned here. Some 2-3 mm you leave it as 30 minus 6 is 24. 24 2 mm gap you give. If you give 22 mm will be the thread length, and choose thread portion and select this cylindrical part. Give this edge as the starting edge and give here finite value. You can give 22 and M12 you select. So the thread has been introduced, only it will appear as a green surface that represents this thing. So I think this part is finished, and will represent and file, save it once you finish all your operations. Okay, and now within itself we will quickly go to the next part, that is seventh part, that is Tommy bar, which is also made up of 410W and 1 mm. Look at this, and here it is shown in balloon callout. This is the Tommy bar, and it is also cylindrical part with 20 mm diameter and 275 mm length. It goes into the screw spindle. To apply the torque manually, we are using this Tommy bar. Here one end is maintained toll dia. So go to solid part. I will use side view YZ plane, and I will draw a 20 dia circle. Excuse me. And what is the length here? 275. 275 is the length mentioned here, and now this 62 mm length, it is maintained as 5 toll dia. You remove the material out of it. You take any face here. I will take this face and quickly draw this 12 mm dia, and up to 60. Use the side step icon to remove the outer material and give 62 is the length. So 62 diameter is maintained. Material is been removed, and here there is a chamfer face with 45-degree angle. You give here setback or edge. You can in this software only you can give the setback distance. You check by trial and error how much you can give. It is a feature field 5 mm setback distance I have given. Reduce this. You can see 4 mm it has taken. Just by trial and error method. You give the a chamfer. Here also you give some small chamfer 1 mm. And then what is this? There is a fillet over here. It is 20 to 10 radius. So if you give, that's enough for this. Now go to round icon. Here radius you give 10 and so it looks perfect, I think. Uh, Here knurling he has mentioned on the surface to have the grip over this cylindrical part. Knurling he has mentioned in this due to some low capability of this software, such features are not there. You just create this geometry. This is enough for you to do this modeling and assembly drawing. Just save it. I have not given this. This is Tommy bar. This number is 7007, and then go to material and look at the material of this. This is Fe410 410 W. Okay. Okay. Now save it. Now all the parts have been created. This modeling process is over. Now you have to do the assembly. I will introduce you in the next session. I will introduce you about the how to do the assembly and what are the assembly features in it. So we will meet in the next session. Okay.